Welcome to the Professor's DuBois channel. This is Professor Corey, and this video is a mini lecture based on our fourth lecture covering material from Chapter 4. This is in no way equivalent to our actual lecture, where we discuss and practice the material in much more detail. We have discussed many different types of reactions that fall into categories of synthesis, decomposition, single and double replacement. These include precipitation, gas forming, and acid-base reactions. Another type of reaction is called an oxidation-reduction reaction, or Redox for short. The reaction shown on this slide is quite spectacular. It is a synthesis reaction, and it is also a redox reaction. The balloon is filled with hydrogen gas and explodes in the presence of oxygen, which is present in air. Notice the burning candle is taped to a meter stick. You do not want your hands near this one. Redox reactions involve the transfer of electrons, much like an acid-base reaction involves the transfer of a proton. Two terms associated with a redox reaction are the species oxidized and the species reduced. The species that loses electrons is said to be oxidized, while the species that gains electrons is reduced. A helpful mnemonic is Leo says Gur, or loss of electrons, oxidation, gain of electrons, reduction. Realize it is only the reactants that are oxidized or reduced in a redox reaction. In the top equation, we have copper ion reacting with magnesium metal. Since the magnesium is in its natural state, we assign the oxidation number of 0 to it. The oxidation number of copper, the copper ion, is the same as the charge. You can see that in this example, copper went from a +2 oxidation number to 0. This is equivalent to gaining 2 electrons. Therefore, copper is reduced. If something gains electrons in a reaction, then something else has lost electrons, and sure enough, the magnesium metal loses 2 electrons to become the 2+ ion and is therefore oxidized. A number line, like the one shown at the bottom, can be useful when trying to determine if a species gains or loses electrons based on the oxidation number change. Oxidation numbers may not always be the charge of the ion. Many elements have several possible oxidation numbers, so it is important to be able to assign the oxidation numbers to all of the elements in a compound. There are 3 elements that almost always have the given oxidation numbers. These are fluorine, oxygen, and hydrogen, with oxidation numbers of -1, -2, and +1 respectively. There are exceptions, but we will not test you on the exceptions. In the first example, we can break apart the salt and assign +1 to the potassium because it is from group 1. Since oxygen is -2, and there are 3 of them, I have a net charge of +1 from the potassium, -6 from the oxygen. In order for the compound to be neutral, the chlorine must have an oxidation number of +5 in this compound. In the second example, the sum of the oxidation numbers must equal the charge on the ion. 7 oxygens yields a net of -14, so each chromium must be +6. If we are given a chemical equation, we could determine if it were a redox reaction by assigning oxidation numbers to every element and looking to see if any of them gained or lost electrons. Since redox reactions are covered in greater detail in a later chapter, we only ask that you are able to assign oxidation numbers at this time. Thanks for watching. Please give the video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.